Okay, guys, so welcome back. In this lesson, we will be explaining to you guys what is work and how to calculate work and how it's linked to energy. Okay, so from a few days ago, you might remember the definition for energy we say is the ability to do work. Okay, but then, well, if it's ability to do work, then what is work? So today we're going to define what work is. Okay, so if we have a force, say there's an object over here sitting on the floor. If we have a force pulling the object, say 100 Newton, and moved the object in the direction of this force for a distance. Say now, should be the front over here. So now it moved over here, 10 meters. If a force moves an object for a distance in the direction of the force, and then we say it has done work. So work equal to force and time the distance. Okay, so this is a new concept we've invented. Is work equal to force times distance. So the equation is force equal work, W, equal to F times the distance. Well, how big is the work? In this situation, we put the number N. It's 100 Newton. They moved a 10 meter. So it becomes 1,000. If we look at the unit, force is Newton and distance is meter. So it's Newton meter. So that's the unit for work. Okay. And then, yep, so that's how you calculate work. But if you say, well, I got a force pushing, say I'm pushing this whiteboard over here. I got a big force pushing it, but the whiteboard is not moving. If it's not moving, there's no distance. Even though you spend a lot of force, but you have not done any work. Okay, so work you have to move. Say, have a distance. So if I'm pushing it this way, but the wind is really strong, it didn't go that way, but the wind has blown it that way. Well, if you are trying to push the object this way with a force, but it did not move in this direction, okay? It started moving in this direction. Then you cannot time these two things together to get work. That's because the object did not move in the direction of the force, okay? So you have to time the direction it's moving, okay? So later I'm going to give you guys some examples where you can see this kind of situation, okay? So now we've also talked about something important is when work is done, so energy is transformed. That's a key thing. When work is done, energy transformed. So we say work equals to the change of energy. Okay, we talk about energy change. So we say, oh, gravitational potential energy turning into kinetic energy turning into gravitational potential energy. So how does this energy changing from one to another? There is always going to be a force involved. And this force have to act for a certain distance to create a work. And this work, the force is down, will equal to the energy transformed. Okay, so let's have a look at example. So example is this. Say if you have an apple, right, sitting on a tree, and the apple is going to fall down a distance. Let's have a look. Well, the distance is going to fall, so force, gravity, is going to do work. Let's say this is a height, right? So, or the distance. So the work is going to equal to this gravity force and time the distance. So now, let's say, what is gravity force? The gravity force is mg. What is the distance? The distance they moved is the height. You can see now work equals mgh, which equal to the gravitational potential energy. Yeah? So you see, in these circumstances, gravitational potential energy is going to turn into kinetic energy. If I ask you, well, why does it turn into kinetic energy? Then you can say, well, it's because the gravity will do work. If the gravity do work, when the work is done, the energy is going to transform from a gravitational potential energy to a kinetic energy. Okay, so that's how energy change works regarding to work. Say you can have another example. Another example is this. Well, say if I have this situation over here, the box is going along the dragged along here. So if I say there is a push force or a pull force, let's say this is a pull, they're pulling the box. If I'm pulling the box, this is gonna do work, 1,000 Newton meter, right? What kind of energy has it turned into? So if you're pulling something, it started moving. So now there will be an increase of kinetic energy. So the amount of kinetic energy you have over here will equal to the amount of work this is done. So at the end, over here, the kinetic energy will equal to 1,000 units is joule. So Newton meter, we can also use joule to represent it, okay? It's the same thing because work is energy, energy is work, okay? So we can use that. So there is only one thing we need to consider here is we're ignoring friction, okay? So if we consider frictions, and then friction will start to do work, okay? So if we don't consider friction in this situation, it's gonna gain 1,000 joule of kinetic energy, okay? All right, so let's say this. For the same question over here, we got some friction. How big is friction? I'm gonna say it's 20 Newton. Okay, if friction is 20 Newton, we want to see, well, how much work has friction done? Because the object has moved in the direction of friction, okay? Even though it's not same direction, it's the opposite direction. So that is still that we consider the same direction, as long as it's like same in the same line, okay? All right, say now, let's say friction work done by friction. That will equal to the friction times the distance. All right, how big is friction? 20 Newton. And time the distance, which is 10 meter. So now friction has to do 200 joule of work. Okay? So, well, I've just mentioned before, if work is done, energy is going to be transformed. Now, if friction is doing work, 2,000 Newton, what is the energy change? Let's have a think. Friction. Friction changes kinetic energy because it has to have a movement, and if it becomes heat, it's gonna heat up, right? Okay, so that's why if friction has done 200 joule of work or 200 Newton meter work, then 200 joule of kinetic energy will turn into heat energy due to friction. Okay, so now we consider this situation together. The kinetic energy was gaining 1,000 because pulling force is doing work, and then 200 of this kinetic energy is going to be lost to heat. Okay, so at the end, so if we combine these two together, what is the kinetic energy? The actual kinetic energy at the end will equal to the 1,000, which is wanted to gain, and take away that 200 from the beginning. So you will have 800 joule of actual kinetic energy at the end when it's over here. Okay, so that is it about work, the definition of work and kinetic energy, how they are linked together. And in your book, I've given you an example as well. So then have a look through the notes, make sure you copy down the notes. If there's anything over here you want to write down, you can write down as well. And then I'm gonna make another video and talk about this bit more difficult question. And then you guys can have a try of the homework, okay? And if there's any questions, just let me know and stay safe. So I'll see you guys in the next video.